combinations. Is that, but that's just beginning of probability. But this course will tell you very systematically and mathematically, so that you can, in other words, you know how to handle in a systematic, rigorous manner to handle things with uncertainty. It has been a mathematics. As you know, mathematics is rigorous, right? Inference, analytical, you can infer what happened. Okay, rather than in your high school, there's almost no theory, very few. Okay, where probability will be needed in your life, like weather. Can you tell me in 10 days the weather, what weather will become? Humidity, temperature, hardly to say that happened. So, or you want to predict the oil price in 3 months. Hard to say what happened, right? Uncertainty. So in your life, there are lots of uncertainties. Then how can you tell in what way you believe that will happen with some probability? But no guarantee it happens. It may happen, it may not happen, right? All those kind of things, lots. And in science and engineering, lots. In electrical engineering, for example, communications, we transmit a sequence of symbols. For example, binary, 1 and 0, a sequence. Then if you're a receiver, you have a handset to receive some signal. You want to detect the sequence you received. Is that correct? Is this a 0 followed by 1, or by 1, 1, or by 0, 0, 1? You don't know. Sometimes you make mistake. So then you need to design your receiver by taking the uncertainty what happened in the signal from the transmitter to the receiver. Even more uncertainty, physical effects, directed path, reflection path, and you never see. Very uncertainty. And for example, in electric transmission or your electronic device, electron moves in the conductor, making some thermal noise. All the electrical devices, thermal noise is there. But can you tell me that what is thermal noise, the waveform? Hard to say, right? It's random. So for those kind of things, then they happen in our available data. Then how do you extract the information from the data, considering those random effects, or even the signal itself is random? Those is you can see lots of phenomena. So probability will be this. I should use my iPad. Let me say, textbook is in the next page. So what we will cover: actions, probability. Probability has some foundation or action. Action means you accept, I accept. As long as we all agree, it's fine. Then we follow this rule, then go through and systematically. Probability is a math now, under some actions to derive things. This is the chapter 1. Definition of probability. Some basic property we will cover. Then combinatorial methods you need to count. Here is kind of a situation. How many possible outcomes? How to calculate the probability? Then conditional probability and independence. Conditional probability means you know something in advance and you try to calculate some events probability with them given you have observed something rather than without that information. That's very important. And independence, events are independent. What does it mean? The distribution function. Then we will start to define random variables. Random variable is not variable, it's a function mapping from events set to a real number between 0 and 1. Then discrete random variables. Discrete means, for example, binary, head and tail, a die, 6 numbers, 1 through 6. They are discrete. Surely they are continuous random variables, and the distribution function. Distribution function is essential. If you are given a distribution function, that random variable is well defined. It's well defined. There are some bivariate, multivariate distributions. Bivariate means two variable. Multivariate distribution. You have 3 or 4 random variables. They have joint probability distribution. So the number of unknown variable, unknown variable itself is random. In computer science, most of the cases, discrete case, QE, is standing in a line, someone after service, he left, and someone come in, it's random in the queue. How many people standing waiting for services? But in EE, electrical engineering, and we receive the signal from the transmitter. The signal is continuous. Your noise is continuous. When you receive it, you decode or demodulate. Then you want to perform detection. Based on that, you receive the signal to judge, to detect, to estimate the parameter. Parameters are continuous parameters. For detection, it may be QPSK for some different symbol sequence. Those are discrete. So you have both cases. You need to make inferences, how to design your detector, maximize your detection probability. Okay, those rely on probability theory. Your background is essential. and something else, linear algebra. Okay, those will be presented, chapter 8 and 9, expectation and the variance. What is expectation? You expect. For example, your grade in class. And those are, what do I expect your performance? To look at your average. This class is very good. Average is more than 80. If the average is 60, probably you can expect that they will get some award or whatever. And variance means what? Fluctuation. Or deviate from the mean value, how much? Statistically. Okay. For example, the river bottom, like assuming the river bottom is not flat, it's fluctuation. If standard deviation is small, then quite flat, you can walk. If the fluctuation is big, even the mean value is the same, but you may cripple, or you may, it's not safe to walk. You must be careful walk through such as those kind of things. So, sum of independent random variables is the limit theorem. Do you know central limit theorem? That means in our life, in science, many things they mixed, like x1 plus x2, etc. How many terms? 10,000 terms. Though all of them are random variable, so what's going to happen? The resulting random variable is going to be a Gaussian. The central limit Gaussian. It's a normal distribution. It's going to be. Many interesting things. Some independent random variables. Those happens in electrical engineering a lot. Here. I have mentioned here some application in, for example, electrical engineering, and some queuing theory, schedule, how you schedule the time for services to optimize the number of services in networking. Those have unique probabilities and foundation. Okay. Okay, then textbook. This is the textbook. This course is my first time teach. Then I'm not sure. Then because the other class also use this textbook. So I think because in computer science they prefer this textbook. In double E, professor may not prefer that much, but I take a look at this course. I want that the subject is not too hard, not too abstract to you. This is just the first fundamental. I want you to learn in depth, and I don't want to frustrate you. It's too hard. But in the future, you need this foundation. So this is the textbook. Fundamentals of probability is stochastic processes, 4th edition. This is the bookstore you can buy. This is a telephone number. I forget to bring my own copy. You can go and buy. Then there's a reference. This is more suitable for double E. I used to teach advanced probability, like stochastic processes, random processes in engineering, or in electrical engineering. This is those are very good author, I believe. I like their book, but this is even more fundamental. Well, I may get some material from here to make up those I feel something missing or whatever. Okay. This is very important to you. You work here. Grading. How this course will be graded. Your grade. We have a midterm exam 50%, and final exam 50%. What about homework? Usually, course, almost every course has you will have some percentage for homework, right? That's general. But through some years experience of teaching, recently I decided not to count homework grade. The reason is, currently you can always find solution from internet, then you lose the chance to do it yourself. I found in the past couple of years, some students, they get very good homework grade, almost 100% homework. The portion may be 20 or 30%. But their examination close to zero. That's not consistent. So I know something is wrong. So then I decide zero. You just need to practice. You hand in the homework, we will grade and give you answers. Don't care about where you get. You try yourself to learn. The purpose is for you to learn rather than you how to get the solution from the internet. Did you follow? And if you get a solution, you lose the chance to practice, to use your theory, to test it if you understand the theory or not. Then even you become a collector rather than you're unable to explain, tell you, analyze the problem. That's different than you didn't learn, that means. So that explains why some students, they get homework almost full grade mark, but examination close to zero. It's inconsistent. So finally, 0%. But if you honestly do, anyways, 0%. There's no need to find, no need to copy someone else. Right? You just practice. If you hand in, then we grade and we return to you then so you can understand where you misunderstand. You can learn. Right? After examination, you know, this is not high school. High school, if you get an 80, is absolute grade. Here is relative grade. That means we can make some adjustments after we the physical turn grade. If that, for example, if the average is 60, it's impossible. Half of the people flunk. That's impossible. The grade, I want to know how much you learn, how deep you learn, rather than I want to see you flunk. That's wrong. That's not the teaching purpose, right? Sometimes if the problem is, examination problem is too hard, average is 40. Most of students, you don't pass. That's wrong. Even sometimes everyone get grade is more than 80, 85. But if you get a chance to work or to do some research, you have no sense. So what does it represent? That's not consistent with your grade, right? So I don't want to see those kind of inconsistency. So if you do your homework, but unfortunately, you didn't get a very good examination grade, then that's good. Take a look. Then I have a mechanism to help people. If you get for example, A minus, I may shift you to A. If you get a C minus or flunk, I may consider to shift you to C. This is the way my advisor, when I was a PhD student, this is the way he gave grades in his class. I don't know why. Then sometimes at the end of the semester, he give a term project. He say, you can, not extra grade, you can ignore it. Then I asked him, should I do the project? You don't need, you have full mark. Why? 你已经很满，你成绩明明是很高，用不着。If you fail or marginal, you better do. And so that you get a chance to, get some raise. So that's the way he did. Sorry. So I try to be flexible. But purpose is for you to honestly learn, and you really actually learn, so that in the future you have an analytical capability. What you say is rigorous and logical. Next step is you have creativity. You can solve challenging problems, all going through logical reasoning, supported by your foundation. This is my experience. I used to have quite some very smart student. They are, I would say, a bright star, bright. Their futures is very bright. Then when you have the capability of creativity and logical reasoning, then you can do something very original, and you can handle very big challenge. Then your boss loves you very much. You feel with full dignity. International world, a lot of people pay attention to you, invite you. So that's good, right? Of course, the money you make usually above average, definitely. Okay. So grading, we have 3 TA. 1, 2, 3. Wei Gang is making a video for recording after class. then you may need to reread, review what the concept you learned. You may forget. No one is perfect with 100% concentration. Sometimes you just fall asleep. Not because you want to do it, but you cannot but 你总是会有时候昨晚熬夜或者什么，你精神不足，那一学期也不可能说都不发生啊，是不是？有什么意外？那还可以看看这个啊。这样，I think it's helpful. Linear algebra is another. I have also another advanced course. It's convex optimization. That's a very powerful mathematical tool of lots of engineers solve very complicated optimization problem. And also published lots of high quality research papers. And that one also, that's served because of the speed for graduate course, usually much faster than undergraduate course. But on the other hand, the number of subjects you learn now, you're taking, in general is more than graduate student. But the course for graduate students is more deeper than, but they don't have too many different subjects. It's much deeper. Research, if you have you have some way to figure out novelty. Novelty means, does that mean just difference? That means advances, not just difference. That's not a novelty. Then you have a novelty. Your work, you can take up a challenge. Then your future, like an exponential going up, rather than exponential that going down. Then you lose the job. Right? That could happen. If you're great, the fundamentals you learn, just good grade, but like your inconsistency with your capability, people will find. Even you have a very good title, then finally you're going to lose your job. Okay. Remark. We have this is the website for this course, and we may have some announcement. You can take a look. And then we have another platform. For example, that platform is ILMS, right? Sometimes in notification, something we announce. You can see how many solutions posted there. So this is the. Sorry, I didn't wear a mask. I have. Wear a mask, then seems I may need. I forgot, but I have. Observe. Observe. Okay. I should. For social distance. Okay. Regarding the way I teach and the lecture time, what I like, we have 2 hours straight, 2 hours each day. But this is a 3-unit subject. I may spend only 75 minutes straight. 2 hours means 100 minutes. But 75 minutes times 2 is 150 minutes, is equivalent to 3 units. The rest of time, I may leave it to TA. He may solve some homework problem. How? So what are your common mistakes? You can help or explain. 这个声音可不可以稍微调小一点？我觉得好像太大。Hello， 这声音怎么样？好像没声音了。OK。Can you hear me well？ 还够大声吗？你如果声音太大的话，很不舒服。我自己听的都觉得好大，所以，但是太小也不好，你就听不到。听不到，maybe you didn't voice。I didn't say, so I didn't know. 所以，林梦轩，我这声音够不够大？有点小吗？
对现场听众来说可能够，可是录影的话可能会有点小。
那这样还是要大声一点。那录影的话就会变成反正，OK。So that's it for the course online and grading. So that's it. And 我需要把这个关掉。关掉什么？We still have 75 minutes. We still have some. Let me switch on the light. Okay, good. The room 216 is very big. 216，它有 two layer 这个 blackboard. So this is only one layer, so 我还是要擦一下，因为 two layers 一次上就够了。You don't need to erase everything still light. So that's briefly 6 about chapter 1. Okay. Chapter 1. I hope if you have an electronic file of the textbook, then I have an iPad, very easy to make notes. 但是那个电子版不能随便 release， 可能是 copyright of the author. Then I don't have the electronic file, so I take notes. That's basic. Chapter 1. I'm talking about what is the probability? introduction, huh? Briefly, just now I have briefly say something. Random. Is it random? Something is random. What does it mean? That means there's some uncertainty. Huh? Is it in an experiment? An event that may or may not happen. Random. That means with some uncertainty. So if they say this event is true, that means that happened. But we're not sure if it is indeed is true. Huh? So an event that may or may not happen is random. It's a random verbal, random process, or random something happens, something may not happen. This is kind of random. You say random. Certainty means what? This is something certain. From now on, then everything we talk, we probably associated with an event. Event. Probability will be defined for every event. Later we will define. If the occurrence of an event is inevitable, then that's a certain. For example, you throw a coin. You possibly have a head, you possibly get tail, only two outcomes, right? Then you define an event. That means tail or head happened. It definitely happened every time you throw. It's either head or tail. That's for sure. As you said with that case. Relative frequency of an event. Frequency. Of an event. What does it mean? We use this notation. For example, the experiment you can repeat many times. You can count how this event it happened. How many experiments? For example, you perform very possibly then in your future, then you have research, you have theory, you want to verify numerically or experimentally of your theories, correct? And you do simulations. For example, you generate 10,000 realizations to see what you analyze or you estimate the results. It's going to be random. Every realization, a random number involved. You can follow your route, your rule, or your algorithm to calculate what you want to do. You estimate to see the statistic is actually that, for example, detection of 4 symbols correctly, correct. How many times they are correct? How many times they are not correct? Or, for example, you throw a die, six numbers, you perform 1,000 times. Then I'm asking you how many of relative frequency, actually 1 through 6, each 1 6, is quite relative. If you have a 100 or 10,000, maybe you perform 10,000 trials. 1 6 is for example, A is an event. Event is a set. Is the for example 1 and 6. How you can count how many 1 and 6 over 1,000 trials. That's relative frequency. 这个大概160就320除以1000，就是这个 event 的相对频率，就是大致上这个概念，出现的多，probability 就大，对不对？这是称为相对频率，就是在我们没有这个非常有系统的 when mathematics is not available, then this is a very logical statement. It is a logical inference, 对不对？是合逻辑的去推理，就是for example, an A happens, then you will say this event is a relative frequency. And A divide 1,000 0.326roughly. Okay, so you will see. If we're very logical, we can do this. Limit n approaches the infinity. NA divided by n. Okay, 那我这个实验的数目次数一直增加，那就会越来越准，会趋近于1/3，对不对？会趋近于，是不是 limit for this case, you throw a die many times, then it should, 对不对？应该趋近于1/3。当然这个 die is unbiased, 是 fair die， 而不是头重脚轻的那种均匀分布。Okay, is that reasonable? Logical reasoning seems correct, right? But you never perform experiment infinitely many times. That's not possible. Huh? Sometimes this sequence does not converge. Or even sometimes it is not justifiable. 但是连证实都没有办法，所以这有它的缺陷，而且 even sometimes it is not unique，有可能数学上是基本上不够隐秘，这是比较古早的做法，对不对？不够隐秘。等到我们数学的好处 ，mathematics is rigorous， 是严密的。是严密的，就是不会出错的。 我们的system, even control system, communication system, based on some assumption, supported by mathematics. The inference is always correct, and you can design, you can repeat. Right? That's in science. Okay, then let me say, this is nothing but a section 1.1 introduction. Then you have already know. Okay, let me say something. Sample space and event. Events. Sample space is a terminology, the definition. Sample space. The patient is S or derivative. This is a set. Is a set, sample space of all possible outcomes of an experiment. 一个实验里面所有可能的结果的集合是 set. Sometimes you see sample points or single points that is the same. Then event. This is the only definition. Definition. Event. If every event is a set, a subset of always say subset because it is a multiple event. Each is a subset of the sample space. Example one. Is like if you're tossing a coin once, what is S? It's going to, you can either head or tail. This is sample space. Okay. Then the second example. You got a bus with 34 passengers. Passengers stops sometime. Between 11 o'clock and 11:40. Okay. What is the sample space for this experiment? All outcome, a set of the outcome. You can define this way. I and T is a pair where I 34, and 0, right?上面车子上面只有坐10个人，10. T is 11 less than 11, 32. T, the T is in hours. 这就是它。假如你这个时间的算法是用小时来计算的话，就是从11点到11用2/3小时，是不是啊？40分钟。那 this is your outcome. How many outcome in the set? I is countable. You know, passenger must be manager, number of passengers. T is a continuous set, right? How many outcome? Infinite. 无限多，是不是？ Okay, this is one way you define your exponent. Another way is also this is I, but now T is in minutes.几分钟？这个时候I is between 34 and 0. Then T is between 40 and 0. Okay? 所以你的 outcome 的结构就会不一样，是不是？所以看你怎么定义的 outcome。将来你的 event 就是这些。If your sample space is defined this way, then your event must be a subset of S rather than this is a different definition of sample space. OK， 那么这样清楚吗？所以如果到11点钟到for example, an outcome. This is an outcome 11. Let's see. Sorry. First is the number of passengers. 31. $11.31. 11.1/3. 这是一个 outcome， 是不是？属于这个 let's say this is S1， 这是 S2， 它就是属于 S1， 不是？一整这样写，这是 subset of S1， 这是集合的符号 set location。Or you can say this is an outcome。一个点一样，就是属于一个集合。你要写成集合的形式，要有大包的，它就是 a set， 就是 single point。OK， then similarly， 你也可以说可以看到31、20。1/3不是20吗？1/3小时20分钟。这个是属于它也许这个就是属于它就是分开的，你定义好you define your sample space, then you just follow probability rule to infer, to compute. Based on the sample space we have. 所以 event sample point 也会结构不一样。Okay, I think probably this is where I should stop. That's a wrong. Then the next is that there are many definitions. That will take some time. Let me see. Do you have a textbook yet? Not yet, right? And the mail. So maybe we stop here. But I still have some interesting things to you. But if we spend another 10 minutes or 15 minutes, if you don't mind, then I can continue. Finish this subsection. Those are just a definition. Okay? So nothing hard to understand. Okay. Event, the notation. This is the whole book. We use E to represent an event. Event. Or, let me say, E and F are events. What does it mean? Event is a subset of sample space. Then this set is a subset of F. With the number of sample points. Each number of outcome in this event is also in F. 就是普通集合的集合的意思，这是 subset。Then equality 就是两个集合相等，就是 constant 的集合 constant 的集合是相等，对吧？这个 this notation 是一个 only only E is a subset of F and F is a subset of E. Then the two sets are equal. This is equality. Okay. Intersection. This is 交集 you know that. Or but in probability in general we describe without this intersection. 就是也用这样的 notation to represent this is intersection. Section. 交集就是同时成立，就是同时成立。That means this event and this event happens simultaneously. Complement. Complement. 这个是 event complement. 就是这个 event 会发生 E only E 不会发生，就是共二 E。An event only occurs whenever E does not occur. 就是它共二，或者互补，difference. One more. The last one. Difference. Event difference. 我们就会写成这样。这个 event 减掉这个，这个是什么？这个集合减这个集合，difference，这是怎么定义的呢？E F complement， 这个集合跟它的 complement 的交集，比如说这个是 E。这个是 F， 一减掉 F 就是一减掉还有它跟 F 共同的，共同的，或者呢，就是一跟这个交集，This is F。The F complement 是这里，一跟 F 的 complement 交集不就这里吗？这是这样，就是这个意思。Okay. Or we say this is a Venn diagram. Venn diagram. 我们假设这个全部都是 S 了，反正它们都是 S 的子集合，那么换句话呢，这个 EC 就是 S 减掉1，S 减掉1剩下的就是它的 complement，这是非常 very straightforward。What is this? This is the green. This is the green. You see. 是 S 减掉1，把它划掉，这是 Venn diagram， 这是Venn diagram。Anyway, this is just definition. The definition. Most of the material in chapter 1 are definition. So that we have foundation too, like 地基，打地基，地基里面放什么？就是很硬的土壤就好，但是也没有，可是地基不稳，上面就会建不好，是不是？地基先搞清楚了，我们再开始一层一层的做，也开始有这个。logical reasoning, etc.
你声音好大声一点。
你看现在够不够大声？
然后我帮你调大声一点。
Okay, then I think time is up, so let's stop here today. So next time is the Thursday at the same time. Okay, you better get a textbook and you need to learn. Okay. 喂，这个比较好 ，very good，
各位不好意思，就是如果有需要我们帮你们代订，就是这门课的 textbook 的话，可以来找我们一下。然后是不是有外籍生呢？Hey, I'm the TA of this semester of this course, and if you need to order food, please come to fill the form. Thank you. 然后就是我们会需要你们先缴，就是一部分的这本书的钱，如果你们要订书的话。 现在付。然后如果钱不够的话，就是你都打勾就可以。1:30之前可以吗？还想到谁？那我给你看一下。
拜拜。
对。